Mountains don't care about confidence. They don't care how long you've lived there, what degree hangs on your wall, or how many winters you think you've survived. In the high country of the American West, winter is not a season. It's a test. By the late 1960s, towns like Crested Butte believed they understood that test. Snow loads were calculated. Roof pitches were standardized. Building codes told people what was safe, what was efficient, and what was considered reasonable. Most homes looked the same for a reason. They followed rules that came from textbooks, not from long winters spent watching snow fall sideways. People trusted those rules because they worked most of the time. But frontier history teaches a hard truth: most of the time is not the same as when it really matters. In mountain towns, real danger shows up when forecasts fail, when storms stall, when snow doesn't fall gently from above, but gets driven like sand across a desert, packing into every crack piling weight where engineers didn't expect it, stealing heat faster than furnaces can replace it. Old settlers understood this. Trappers, homesteaders, and mountain families didn't talk about extreme weather events. They talked about winters that killed livestock, collapsed barns, and trapped families for weeks. Survival wasn't about comfort. It was about staying alive without outside help. That kind of knowledge didn't come from plans stamped by an office. It came from mistakes, from roofs that failed, from cabins that froze solid, from watching which structures lasted and which ones disappeared by spring. By the mid-20th century, much of that thinking had faded. Modern materials and cheap energy gave people confidence. Snow was something you plowed. Cold was something you heated away. Nature became a problem to overpower, not a force to work with. That confidence worked until it didn't. This story begins at the edge of that assumption. In a small mountain town, just before winter reminded everyone who was really in charge. When one man built something that looked wrong to everyone else, not because he ignored physics, but because he understood it differently. And the mountain was about to decide who was right. The man at the center of this story did not arrive with big plans or loud opinions. He arrived with habits. He woke early. He worked alone. He paid attention to small things most people ignored. How snow stacked against a fence. How wind scoured one side of a slope bare while burying the other. How silence settled differently after heavy snowfall. Before he ever built anything in the Rockies, he had already spent a lifetime watching winter. He grew up in a mountain farming community where survival depended on understanding seasons, not fighting them. As a boy, he learned that snow was not uniform. Some storms brought wet, crushing weight. Others brought dry powder that moved like smoke in the wind. Each kind demanded a different response. His education did not come from classrooms. It came from barns that still stood after a century, from roofs shaped not for beauty but for endurance, from elders who explained why things were built the way they were, not just how. When he immigrated to the American West, he noticed something right away. People here knew winter, but they didn't watch it the same way. They measured snow depth. He watched how long it stayed. They calculated weight. He observed movement. They trusted averages. He planned for exceptions. He wasn't dismissive of American building methods. He simply didn't believe they were complete. To him, many structures looked like they were designed for polite winters, winters that followed the rules. But mountain winters don't follow rules. He didn't argue with neighbors. He didn't try to convince anyone. He knew something most frontier builders eventually learn: explanation is weaker than proof. So instead of talking, he built, not quickly, not cheaply, and not in a way that made sense to people used to standard houses with modest overhangs and shallow pitches. What he was building came from a different logic, one shaped by generations of trial, failure, and correction. To outsiders, it looked excessive, wasteful, even dangerous. To him, it was careful. He wasn't trying to defeat winter. He was trying to give it somewhere to go. And that difference between resistance and cooperation would soon become impossible to ignore. When the frame began to rise, people stopped calling it a cabin and started calling it a mistake. The walls were normal enough. Small, practical, nothing fancy. But above them grew a roof that made no sense to anyone watching. It stretched far beyond the cabin's footprint, throwing shade where no one expected shade. Its pitch climbed steep and sharp, far steeper than local practice. From a distance, it looked oversized, unbalanced, almost reckless. In a town where most roofs followed the same logic, this one felt like an insult to common sense. Neighbors asked the obvious questions. Why so much overhang? Why waste that much lumber? Why build something that catches wind like a sail? Contractors shook their heads. They'd spent years learning what worked here. 3-foot overhangs, reasonable slopes, designs that met code and passed inspection. What stood in front of them ignored all of that. The roof didn't just break convention, it broke expectations. People assumed the builder was stubborn, maybe proud. Some thought he was nostalgic, trying to recreate something that belonged in another country, another climate. Others thought he simply didn't understand Colorado snow. What no one considered was that the roof wasn't meant to hold snow at all. In modern thinking, roofs are containers, and you calculate how much weight they can support and hope the storm stays within that limit. This roof was designed with a different goal. It wasn't built to resist accumulation, it was built to prevent it. The steep pitch meant snow couldn't settle. The metal surface reduced friction. Gravity did the rest. Snow that landed didn't stay long enough to become dangerous. The wide overhang wasn't decoration. It wasn't shelter for aesthetics. It was space-intentional space where falling snow could land, drift, and pile without threatening the structure itself. To people used to static buildings, this looked wrong. Buildings were supposed to be fixed, passive, predictable. This one was active. It was designed to move snow-shaped wind and create calm where chaos usually lived, but that logic wasn't visible yet. All people could see was a roof that looked too big for its own good, and winter was coming fast enough to test it. Engineers are trained to prepare for failure. They calculate load stresses and safety margins because structures don't get second chances. When something collapses in winter, people can die. So when professionals looked at that roof, their concern was real. They did the math the way they were taught. Snow load per square foot, average accumulation, worst case depth, add a margin, multiply by area. The numbers climbed fast. Too fast. On paper, the roof looked like a liability. From a static standpoint, it appeared to ask a small number of posts to carry an unreasonable amount of weight. Add wind pressure, add ice, add uncertainty, and the conclusion seemed obvious. Sooner or later, the structure would fail. But those calculations made one quiet assumption. They assumed the snow would stay. Most engineering models treat buildings as passive objects. Snow falls, piles up, and sits there until someone removes it or it melts. That assumption works for shallow roofs, rough surfaces, and moderate climates. It doesn't work for steep, slick surfaces designed to shed load continuously. The roof wasn't meant to carry snow for days or weeks. It was designed to carry it for minutes, maybe hours, just long enough for gravity to move it somewhere else. That difference matters. If snow never accumulates, peak load never occurs. If weight is constantly transferred to the ground instead of held overhead, the structure behaves very differently from what the equations predict. Wind was another blind spot. Engineers calculated wind as a force pushing against the structure. The roof treated wind as something to redirect. The steep pitch forced airflow up and over, reducing pressure instead of absorbing it. These ideas weren't new. They just weren't common in modern residential construction. The problem wasn't bad engineering. It was incomplete modeling. The roof wasn't a static structure. It was a system, one that used motion, gravity, and weather patterns as part of its design. And systems don't reveal their strength on paper. They reveal it in motion. Winter would soon provide that motion. The strength of the roof didn't come from steel brackets or factory-made connectors. It came from wood cut slowly, fitted carefully, and joined the way people had done it long before power tools existed. The main supports were large, far larger than modern framing lumber. Thick posts set deep into the ground below the frost line where winter couldn't heave them loose. Horizontal beams were squared by hand, not shaved down to save weight or cost. Every piece carried mass on purpose. What held it all together wasn't nails. It was joinery. Mortise and tenon joints locked each beam into the next. Wooden pegs expanded inside their holes as humidity changed, tightening the structure over time instead of loosening it. Where metal fatigues, wood flexes. Where bolts shear joints distribute force. Modern construction favors speed. Nail guns, lightweight lumber, standardized parts that can be assembled quickly by crews on tight schedules. That approach works well until wind begins to twist instead of push and snow loads shift instead of settle evenly. Old joinery behaves differently under stress. When wind hits a heavy timber frame, the structure doesn't resist it rigidly. It moves slightly. That movement absorbs energy. It spreads force across the frame instead of concentrating it at one weak point. This is why many 19th century barns still stand while newer sheds collapse. Not because builders were smarter, but because they built for uncertainty. The roof's frame acted like a single organism, not a stack of parts. Each joint shared the load. Each beam supported the others. Failure would require many things to go wrong at once, not just one connection breaking. That kind of resilience isn't efficient by modern standards. It uses more material. It takes more time. It demands patience and skill. But it also survives conditions that fast building does not. This wasn't nostalgia. It was risk management. The roof wasn't just big, it was forgiving. And when winter applies pressure unevenly, as it always does, that forgiveness makes all the difference. Most people see snow as a problem to remove. You shovel it, you plow it, you scrape it off roofs before it becomes dangerous. That mindset makes sense if snow is something that threatens your structure. But in older building traditions, snow was treated differently. It was seen as a material unreliable, shifting, but useful if handled correctly. Snow insulates. Packed snow blocks wind. Deep drifts can protect lower walls from extreme cold. The danger isn't snow itself. The danger is where it ends up. The roof was designed with this in mind. Its steep pitch didn't just shed snow, it controlled where the snow went. Instead of letting it fall close to the walls, the long overhang pushed it far enough out to form a perimeter. Over time, that falling snow built up into dense banks shaped by wind. Those banks became walls. Not walls made of wood or stone, but walls made of compressed snow hardened by wind and cold. On the windward side, they grew tall and solid, absorbing gusts that would otherwise slam into the cabin. On the leeward side, they stayed lower, allowing airflow without turbulence. This wasn't accidental, it was predictable. When snow slides off continuously, it never loads the roof heavily. Instead, it transfers weight to the ground exactly where weight belongs. The structure above stays light. The environment below becomes protective. This is why the roof didn't fear deep snowfall. In a heavy storm, more snow actually made the system work better. Higher walls meant better wind protection, better insulation, more stability. Modern buildings try to isolate themselves from weather, seal it out, push it away. This design did the opposite. It invited snow to participate. Once you understand that the roof stops looking excessive, it starts looking intentional. Snow wasn't the enemy threatening collapse. Snow was part of the structure. The storm wasn't supposed to be memorable. Weather reports called for a foot of snow, maybe a little more at higher elevation. Cold, yes. Windy, certainly. But nothing outside the range of a normal early winter system. People stacked firewood, checked vehicles, and went about their routines. Then the storm slowed down. Instead of moving through the mountains, it stalled. Snow that should have ended by morning kept falling into the afternoon. Then through the night. Then into the next day. Wind picked up and stayed there, pushing snow sideways, packing it into drifts that erased roads and buried fences. Power went out early. Lines snapped under ice and wind. Radios crackled with incomplete updates before going silent. By the second night, the town was effectively cut off. This is when winter changes character. A mild inconvenience becomes isolation. A storm becomes a situation. Heat, light, and access matter more than comfort. People stop thinking in hours and start thinking in days. Snow piled up fast. Roofs disappeared under white weight. Some sheds began to groan. Doors drifted shut. Vehicles vanished beneath waves of powder hardened by wind. This was the kind of weather that exposed weak decisions. People worried about elderly neighbors, about livestock, about whether their wood would last. Nobody worried about the strange roof on the edge of town, not yet. Most assumed the worst had already happened there. When visibility dropped to a few yards and wind gusts pushed people backward, a small group decided to check anyway. They expected damage, maybe collapse, maybe someone trapped or injured. What they found instead forced them to rethink everything they thought they understood about winter and shelter. The storm had come to prove a point, and it wasn't finished yet. What they expected to see was failure. A roof bent under weight, broken supports, snow packed so thick it pressed against windows and doors. That's what usually happens when a structure meets a storm like this. Instead, they saw order. The roof was still there, unmoved, unbowed. Snow was everywhere else, on other cabins, on sheds, on equipment, but not on the roof itself. The steep metal surface was nearly clean, the snow sliding off as fast as it landed. Around the cabin, something else had formed. A ring of snow piled high, dense, sculpted by wind. On the side facing the storm, it rose like a wall. On the sheltered side, it sloped gently away. The ground under the massive overhang was mostly clear. Tools were dry. Firewood was stacked and usable. There was space to move. The roof hadn't fought the storm. It had redirected it. Snow that would normally sit overhead had been moved to the perimeter. Wind that would normally slam into walls had been pushed up and over the structure. What looked like chaos from the road became calm beneath the roof. They stepped inside the covered area and felt it immediately. Less wind, less bite in the air. The difference wasn't subtle. It was physical. This was the moment the calculations failed. All the numbers assumed accumulation. They assumed snow stayed where it fell. They assumed wind pressure acted directly on walls. None of that was happening here. The roof was shedding load continuously. The weight was never allowed to build. The structure wasn't experiencing maximum snow load because that condition never existed. Gravity was doing the work. Wind was being used instead of resisted. Snow was being placed where it added protection, not danger. This wasn't luck. It was design that only makes sense once it's moving. Physics hadn't been ignored. It had been applied in full. And once you see that the roof stops looking strange, it looks honest. It looks like someone understood winter well enough to let it show what it can do without destroying what was built beneath it. The most important thing the roof created wasn't shelter, it was difference. Step a few feet outside the overhang and the storm was violent. Wind cut through layers, snow stung exposed skin, sound disappeared into the roar. But under the roof, the air changed. Movement slowed, noise dropped. The cold felt muted, not gone, but softened. That difference is a microclimate. It's a small localized environment shaped by structure, terrain, and materials. Long before the term existed, frontier builders knew how to create them. Not with machines, but with form. The wide overhang blocked falling snow. The snow walls blocked wind. The roof trapped a pocket of still air. That air warmed slightly from ground heat, body heat, and any fire burning nearby. Even a few degrees made a real difference. This is why old animal shelters were built low and tight. Why snow fences were placed where drifts would form on purpose. Why igloos made entirely of frozen material could be warm inside. The roof worked the same way. It didn't heat the space. It protected it from losing heat too quickly. That's the part modern systems often miss. Insulation isn't about warmth. It's about slowing loss. Under the overhang, tools didn't freeze. Wood stayed dry. Ice didn't creep into joints. Work could continue even during the storm. This mattered more than comfort. In winter, productivity equals survival. The ability to split wood repair tools and move freely without exposure keeps small problems from becoming emergencies. The microclimate extended the usable space of the cabin far beyond its walls. The living area was small, but the sheltered area made life larger. Storage, work, movement, all protected. Modern homes shrink in winter. People retreat indoors and wait it out. This design expanded. It created space when the world outside was trying to close in. That's not luxury, that's resilience. And once you recognize that the roof stops being about size, it becomes about control over loss exposure and time. What happened during that storm wasn't luck, and it wasn't genius in the modern sense. It was slow knowledge at work. Frontier wisdom doesn't come from one good idea. It comes from many bad winters. From structures that failed, animals that died, and people who had to live with the consequences long after the mistake was made. Each generation adjusted a little. Changed an angle, extended an overhang, moved a post, then watched what happened. That process takes time, decades, sometimes centuries. Modern building culture doesn't work that way. It favors speed and standardization. Designs are tested in simulations, approved once and repeated everywhere. That efficiency is useful, but it assumes conditions stay predictable. Frontier builders never assumed that. They expected variation. They planned for the year when snow came early, stayed late, and fell heavier than anyone remembered. Their structures weren't optimized for average conditions. They were built for the outliers. That's the difference. Slow knowledge doesn't look impressive at first. It often looks outdated, inefficient, or excessive. Extra wood, extra labor, extra caution. But those extras are what absorb uncertainty. The roof was a product of that thinking, not copied blindly from the old country, but shaped by the same mindset. Observe first, build second, adjust always. This is why the builder didn't argue with critics. He didn't need to defend the idea. He trusted the process that produced it. The same process that had kept barns standing and families alive long before anyone talked about safety factors. Slow knowledge doesn't demand belief. It waits for proof, and winter sooner or later always provides proof. The storm made visible something that usually stays hidden, the value of patience, of observation, of designs shaped by time instead of trends. That lesson doesn't just apply to buildings. It applies to how people survive hard places, hard seasons, and hard years by listening longer than they speak and by letting experience, not opinion, do the talking. After the storm, the town changed, but not all at once. At first, people just noticed small things. One roof still clear, one yard still usable, one place where snow hadn't swallowed every path. Curiosity replaced jokes. Silence replaced criticism. No one made announcements. No one apologized right away. That's not how mountain towns work. People watched. They compared what they'd struggled through with what they were seeing now. Frozen doors, collapsed sheds, wet firewood. Then they looked again at the big roof that had been called foolish, wasteful, dangerous. What stood out wasn't that it survived. It was how usable it remained. While others were digging just to reach their doors, work continued under that overhang. Tools stayed dry. Wood stayed split. Space stayed open. The storm hadn't paused life there, it had barely slowed it down. That made people uncomfortable. Because if the roof worked, then the assumptions didn't. It meant the rules everyone trusted weren't complete. It meant experience from somewhere else, older experience, still mattered. And that's a hard thing to accept, especially when you've done things the same way for years. Some folks came by with questions. Casual at first, then more specific. Why that angle? Why that distance? Why no snow buildup? The answers were simple, direct. No lectures, no pride. Snow slides, wind lifts, weight moves. That was it. The shift didn't happen because someone was proven wrong. It happened because something was proven useful. In places like this, usefulness outranks theory every time. People began to look at their own buildings differently, at their overhangs, at where snow piled up, at how wind moved around corners. Things they'd seen before but never really noticed. The roof didn't just change one property, it reset attention. And once people start paying attention again, old knowledge doesn't sound old anymore. It sounds practical. It would be easy to treat this story as a local curiosity, a clever solution for one place, one man, one winter long ago. But that misses the point. What that roof demonstrated is becoming relevant again fast. Weather is less predictable now. Storms stall longer. Snow falls heavier in places that didn't plan for it. Energy costs rise. Supply chains fail when roads close. In those moments, systems that depend on constant outside support stop working the way they were promised to. The roof didn't need fuel. It didn't need power. It didn't need emergency repairs. It worked because it was shaped to the environment, not insulated from it. Modern buildings often rely on active systems to correct passive mistakes. Heaters compensate for heat loss. Fans fight condensation. Reinforcements fix loads that shouldn't have built up in the first place. That approach works as long as everything else works too. Frontier designs assume things will fail. Power will go out. Fuel will run low. Help will arrive late, if at all. When that happens, the structure itself has to do more of the work. The roof did exactly that. It reduced heat loss instead of increasing heat production. It managed snow instead of removing it. It created usable space instead of shrinking life indoors. Those are not old ideas. They're resilient ones. For people interested in off-grid living, minimal energy use, or simply aging in place without constant dependence, these principles matter. They reduce labor. They reduce risk. They increase margin. This isn't about copying the exact structure. Few people need a roof that large. It's about copying the thinking behind it. Watch the environment. Identify what causes loss. Redirect forces instead of resisting them. That mindset scales from cabins to barns to workshops to modern homes. The roof mattered because it proved something simple and uncomfortable. Progress doesn't always mean replacing old ideas. Sometimes it means remembering why they existed in the first place. The lesson of the roof is not about copying shapes, it's about copying relationships. Nature applies forces in predictable ways. Snow falls, wind moves, cold pulls heat away. Problems begin when buildings ignore those forces or try to overpower them with energy and materials. Frontier builders took a different approach. They asked one question first: where does this force want to go? Snow wants to slide downhill, so you give it a steep path and a place to land safely. Wind wants to flow, so you guide it up and over, not straight into a wall. Cold wants to steal heat, so you slow that process instead of constantly replacing what's lost. That thinking shows up in small details. Longer overhangs keep walls dry and protect foundations. Steeper roofs reduce maintenance and prevent overload. Covered outdoor space extends work seasons without heating more square footage. Dry wood storage near the house saves labor and fuel. None of this is complicated, it's just intentional. Modern construction often separates function into systems. Heating does one job, roofing does another. Storage is an afterthought. Frontier design integrates them. One element serves multiple purposes at once. That integration matters more as people age. Clearing snow becomes harder. Repair work becomes riskier. Dependence on machinery becomes more fragile. Structures that reduce daily effort aren't conveniences, they're safeguards. Building with nature doesn't mean surrendering to it. It means aligning with it. You still choose materials. You still plan carefully, but you let gravity, wind, and snow do part of the work instead of fighting them every day. The roof succeeded because it didn't demand constant attention. It didn't need daily shoveling or emergency reinforcement. It took pressure off the person living beneath it. That's the real benefit. Good design reduces decisions. It reduces effort. It buys time. And in harsh places, time is the most valuable resource you have. The roof didn't make its builder famous. There were no patents, no lectures, no movement built around his name. He didn't argue online, didn't write manuals, didn't try to prove anyone wrong. He lived under the roof, worked beneath it, and let winter test it year after year. That's how frontier knowledge survives. Not through recognition, but through usefulness. Civilizations aren't carried forward by the loudest voices. They're carried by people who solve real problems quietly, then pass those solutions along without ceremony. A better way to join two beams, a smarter place to store wood, a roof angle that sheds danger instead of collecting it. These things rarely look impressive at first. They don't signal status. They don't fit trends. Often they look strange until conditions get hard. Then they matter. The men and women who built the frontier didn't aim to be remembered. They aimed to make it through winter. Their success wasn't measured in admiration, but in survival. If a structure worked, it stayed. If it failed, it disappeared sometimes with its builder. That kind of feedback is honest. The roof stands today not because it was celebrated, but because it was right. It did what it was built to do without needing permission or approval. There's something steadying about that. In a world full of noise, the roof reminds us that truth doesn't require consensus. It only requires contact with reality. Snow, wind, cold, they don't care what you believe. They respond to form physics and preparation. The quiet men understood that. They watched longer. They built slower. They trusted experience over confidence. And when the storm came, they didn't need to explain themselves. The structure did it for them. That's the frontier spirit worth preserving, not nostalgia, not aesthetics, but respect for forces bigger than us, and the humility to work with them instead of against them. Because long after opinions fade, the roof still stands, and winter still tests everything.